First appearing in the 1999 video game Sid Meier's Alpha Centauri, the planet Chiron is presented as the first exoplanet colonized by humans. The planet supports a diverse ecosystem of native multicellular life forms approximating earthly flora, fauna, and fungi, all existing in a symbiotic web of high bioefficiency. The most advanced life form on Chiron is the so-called xenofungus, which forms enormous fungal mats that stretch across nearly 1/4 of Chiron's surface and interconnect, forming a global neural network that many believe possesses a unified sentience in a near-conscious or quasi-conscious state. Chiron is a wet terrestrial with a reported surface water coverage of approximately 71%. It has a mass 82% higher than Earth's and a size 18% larger. This gives it a surface gravity of 1.3 g and an abnormally high mean density of 6.05 grams per cubic centimeter, indicating that it possesses a sizable nickel-iron core. Chiron's atmosphere is comprised of 91% nitrogen, 8.5% oxygen, and 0.01% carbon dioxide, at an average surface pressure of 74% higher than Earth's. Although the lower levels of greenhouse gases in its atmosphere allow it to lose more heat to space, the planet receives about 27% more energy from its parent star than Earth does. This places its average surface temperature between 18 and 20 degrees Celsius, and its near-zero obliquity results in virtually no seasonal variations throughout its year. The planet is said to be so warm that it does not possess any polar ice caps, resulting in it having a slightly lower albedo than Earth, which further increases the average surface temperature by absorbing more of the star's light. The high temperatures also produce intense storms along the planet's equator that spin off dangerous cyclones and frequently devastate nearby landmasses. Chiron is orbited by two major moons, known as Pholus and Nessus. The innermost moon, Pholus, orbits at an average distance of 0.25 lunar distances, with a period of 61.49 hours. It has a mass of only 1% that of Luna and is 20% the size, barely large enough to be a spherical object. It has a surface gravity of 0.04 g and a mean density of 4.18 grams per cubic centimeter. The outermost moon, Nessus, orbits at an average distance of 0.52 lunar distances with a period of 7.61 days. It has a mass 9% that of Luna and is half the size, giving it a surface gravity of 0.06 g and an abnormally low mean density of 2.4 grams per cubic centimeter, suggesting that a significant portion of its mass is comprised of ices, which is rather unlikely given its distance from the star. It is reported that eclipses of Nessus by Pholus occur regularly due to both moons orbiting within Chiron's equatorial plane with zero eccentricity. However, such orbits are virtually impossible given the energetic means by which terrestrial moons are formed. Chiron is the second of two planets in the Alpha Centauri A system and orbits its yellow star at an average distance of nearly 160 million kilometers, or 1.07 astronomical units, giving it an orbital period of 387.78 days, or 532 local days, given the planet's synodic rotation period of 17 hours and 28 minutes. Chiron's parent star, Alpha Centauri A, also known as Rigel Kentaurus, is a spectral type G2 main sequence yellow dwarf 8% more massive than our Sun and 51% more luminous. It is the primary member of a trinary star system and orbits its orange companion, Alpha Centauri B, also known as Ptolemy, or Hercules to the residents of Chiron, at an average distance of 17.5 astronomical units with an eccentricity of 0.519. This brings the two stars to within 11.5 astronomical units approximately every 80 years. The red dwarf star Alpha Centauri C, otherwise known as Proxima Centauri, orbits the AB pair at an average distance of approximately 8,700 astronomical units with a period of over 547,000 years. So how does Chiron measure up scientifically? Chiron's mean density is unusually high for a planet of its mass. However, the fact that it and its sibling planet Eurytion are the only two planets orbiting Alpha Centauri A makes this a bit more plausible. It is possible that as Alpha Centauri b truncated A's protoplanetary disk, it also caused the edge of the remaining disk to essentially fold back on itself, increasing the disk's density and allowing the two planets forming there to absorb more iron than they could have otherwise. So, 1 point. The basics of Chiron's orbital characteristics are present and accurate, so I will give it the point. However, I will have more to say on this in just a bit. Chiron's atmosphere is obviously where its creators focused the majority of their efforts. Literally pages of text were authored to explain how the atmosphere's composition, pressure, and temperature affect the planet's diverse native ecology and the Earthling colonists. 1 point. Chiron's satellite system is where its realism falters the most. Terrestrial planets such as this are not capable of forming multiple spherical moons, as their low mass prevents them from forming moons through accretion, as Jovian planets do, and leaves only large impacts as their source. But after the first moon is formed in this way, it dominates the orbital space around its parent planet and prevents the formation of subsequent moons. This method of forming moons is also why the zero eccentricity and zero inclination orbits of Chiron's moons are anomalous. Protoplanetary impacts are neither gentle nor orderly and thus result in an object with a significant eccentricity and inclination to its orbit. For both of Chiron's moons to lack these features further compounds their impossibility. -1 point. Unsurprisingly, Chiron's stars are depicted realistically, as they are actual stars. But the developers of Sid Meier's Alpha Centauri did well to consider the effects of having two stars in such close proximity to one another, and wisely limited the size of the planetary system to just two relatively small planets. Quite unlike a more recent science fiction franchise that placed complex planetary systems the size of our own around both of the stars. Unfortunately, the Alpha Centauri system is not a good option for the placement of an Earth-like planet, but being the closest star system to our own means that the developers of this video game were stuck with it. Overall, I feel they did a good job playing the hand that they were dealt. 1 point. Before I assign Chiron a grade, I have one final issue that I wish to discuss, and that is how everything is a perfect circle. For instance, Chiron has a faster rotation rate than Earth does, so its equatorial radius should be greater than its polar radius due to centrifugal force. This quality is referred to as the planet's oblateness, and Chiron should have an oblateness at least as high as Earth's and likely a bit higher. However, its oblateness is never stated, and so we can only describe the planet as a perfect sphere. Similarly, the presence of Alpha Centauri b should tug on Chiron's orbit and give it some degree of eccentricity. All planets have some amount of eccentricity to their orbits, but this one should especially. And yet, no eccentricity is stated, leaving us only capable of describing its orbit as a perfect circle. This is then echoed in Chiron's satellites, which are both specifically stated to have no eccentricity to their orbits. Now, I know that one could argue that Chiron does actually have both oblateness and eccentricity, it's just that these values were simply not published. But that's a lame excuse. When you give a planet exotic properties or place it into an exotic environment, those will have ramifications for the planet's parameters. Neglecting to explore those ramifications not only deprives the planet of the things that truly make it alien and unique, but make it appear incomplete at best and at worst unrealistic. Now, I'm not going to strip Chiron of a point for this, but it does deserve to be called out for such an important oversight. With a total of 3 points, the planet Chiron from Sid Meier's Alpha Centauri receives a B grade. Overall, the creators of this planet did a good job crafting it. Thank you for joining me on this planetary analysis. If you enjoyed it, please don't forget to give it a like and subscribe so that you don't miss out on any future explorations. Until next time, keep exploring.